Dear students, I am Dr. Tamrakar from Bharati College of Engineering and Technology, Durg. I am teaching food machinery in BE 5th semester. Today we will solve one numerical. An outward flow reaction turbine has internal and external diameter of the runner as 0.6 meter and 1.2 meter respectively. The guide plate angle is 15 degree and velocity of flow through runner is constant and equal to 4 meter per second. If the speed of turbine is 200 rpm, head on the machine turbine is 10 meter and discharge at outlet is radial. Determine first the runner vane angle at inlet and outlet. Second, work done by the water on the runner per second per unit weight of water striking per second. Hydraulic efficiency, and fourth, the degree of reaction. Here the data given: internal diameter D1 equal to 0.6 meter, external diameter D2. Here this is the outward reaction flow turbine, so internal diameter is D1 and this is less, and external diameter is D2 and the value of D2 is 1.2 meter, means external diameter is broader. Okay. Globe guide blade angle alpha equal to 15 degree. Velocity of flow that is Vf1 equal to Vf2 equal to 4 meter per second. Speed n is given 200 rpm. Head H is given 10 meter. Discharge at outlet is radial. Outlet, that is W2 equal to 0 and Vf2 equal to V2. Tangential velocity of runner at inlet and outlet are U1 equal to pi D1 and by 60 equal to pi into 0.6 into 200 by 60. So this comes 6.283 meter per second, and U2 equal to pi D2 and by 60 equal to pi 1.2 into 200 by 60. This comes 12.566 meter per second. From inlet velocity triangle, here the velocity triangles are alpha, this is V1, U1, VW1, VF1, VR1, this is angle theta, this is the turbine plate, and this is for radial discharge, this is U2, angle phi, angle beta equal to 90, VF2, V2, VR2, this means VR2, here, and these are R1, and this is R2, out. Okay. So here from the inlet velocity triangle, tan alpha equal to VF1 by VW1, so that is tan 15 equal to 4 by VW1. So the value of VW1 comes 14.928 meter per second. So here runner vane angle at inlet and outlet are theta and phi. So finding the angle theta, tan theta equal to VF1 by VW1 minus U1. Putting the values here, 4 divided by 14.928 minus 6.283. This comes 0.4627. So the value of theta comes 24.83 equal to 24 degree and 49.8 minutes is value of theta. Tan phi equal to VF2 by U2, that is 4 by 12.566. So phi equal to 70.65 degree equal to 17 degree 39.4 minutes. This is the angle phi. Now work done by water per second per unit weight of water striking per second, work done equal to 1 by G VW1 U1 when VW2 equal to 0. Here VW2 equal to 0. Okay. Putting the values here, 1 by 9.81 into 14.928 into 6.283. So this comes 9.561 Newton meter per Newton is the work done. Next, hydraulic efficiency. Hydraulic efficiency equal to V W1 U1 by GH. Putting the values here, 14.928 into 6.283 by 9.81 into H is 10. So this comes 0.9561, that is 95.61% is the hydraulic efficiency. Next, here, given this question, the velocity of flow is constant through runner, that is Vf1 equal to Vf2, and the discharge is radial at outlet, that is beta equal to 90 degree, and Vw2 is given 0. These data have been given. The degree of reaction is given by equation R equal to 1 minus cot alpha divided by 2 cot alpha minus cot theta. Okay, here alpha equal to 13.928 and theta equal to 41.09. We have just calculated. So substituting the values here, R equal to 1 minus cot 13.928 to cot 13.928, and minus cot 41.09. So here the value 1 minus 0.698, that is equal to 0.302, that comes 0.3 is the degree of reaction comes here. We have to solve similar type of questions, and the questions asked in the examination, that is very important. Next question we'll solve. The internal and external diameter of an outward flow reaction turbine. देखिए यहाँ क्वेश्चन में सबसे पहले आपको क्लियर कर दिएगा कि आउटवर्ड है ना, तब आपको ये फॉर्मूले लगाने होंगे. R 2 meter and 2.75 meter respectively. The turbine is running at 250 rpm and rate of flow of water through the turbine is 5 meter cube per second. The width of runner is constant at inlet and outlet and is equal to 250 mm. The head on the turbine is 150 meter. Neglecting thickness of vane and taking discharge radial at outlet, determine vane angle at inlet and outlet and velocity of flow at inlet and outlet. Here the data given: internal diameter d1 equal to 2 meter, external diameter d2 equal to 2.75 meter, speed of turbine N is given 250 rpm, 250 rpm, discharge Q is given 5 meter cube per second is discharged, width at outlet at inlet, that is B1 equal to B2 equal to 250 mm equal to 0.25 meter, head is given 150 meter, discharge at outlet radial, discharge at outlet is radial, that means VW2 equal to 0 and VF2 equal to V2. Okay. The initial velocity of turbine at inlet and outlet, we have to calculate U1 equal to pi d1 and by 60. So this is pi and d1 is 2 into 250 by 60. This value comes 26.18 meter per second. U2 equal to pi d2n by 60 equal to pi 2.75 into 250 by 60. This comes 36 meter per second. This is the inlet and outlet velocity angle of the outward turbine, radial flow reaction turbine. Here we have to, let's discuss the discharge through turbine is given by Q equal to pi d1 b1 vf1 equal to pi d2 b2 vf2. These are b1 and b2. Okay, not beta. Okay, so here vf1 equal to q by pi d1 b1. Putting the values here, this is 5 into d is 2 and b is 0.25. So vf1 equal to 3.183 meter per second and vf2 equal to q by pi d2 b2 5 pi 2.75 into 0.25. So this value comes 2.315 meter per second. Now, using the relation h minus v2 square by 2g equal to VW1 U1 by G, because VW2 equal to 0 radial, because this is radial. Now putting the values, 150 minus 2.315 square by 2 into 9.81 equal to VW 2, which is VW2. This one is used as VW2 or VW1, both can be written. So here we use VW2 into 26.18, that is U1 by 9.81. So from here the value of VW1 comes 56.1 meter per second. Now, when angle at inlet and outlet tan theta equal to VF1 by VW1 minus U1, putting the values here, 3.183 by 56.1 minus 26.18 equal to 0.1064. So the value of theta comes 6.072 degree. That is equal to 6 degree 4.32 minute is the value of theta here, and tan phi equal to, from velocity outlet triangle, VF2 by U2, putting the values here, 2.315 by 36. So here the value of phi comes 3.63 degree or 3 degree 40.8 minute is the value of phi here. Now velocity of flow at inlet and outlet, VF1 equal to 3.183 meter per second and VF2 equal to 2.315 meter per second. So you have to solve more and more numericals from question papers. Thank you.